In this video, we will discuss a tool for generating pseudocode from C. Pseudocode is the natural language description of a segment of code written for human readability. It is used to describe the process of an algorithm or appended as a comment to aid in understanding an already implemented program. Now, this tool aims to generate pseudocode from any piece of C and ease comprehension of source code. For this program, we're using an open source tool called Pseudogen. Pseudogen was originally used for converting Python to pseudocode, and we have extended it to support C. It uses tree-to-string and phrase-based machine translation and integrates the tools Travatar and Github. It is useful because it helps users to grasp unfamiliar source code. It can aid code comprehensibility for code bases with a large number of contributors, thus spending less time trying to understand the source code and more time working with it. Here is a diagram showing how to train Pseudogen from C source code and English samples. The training data consists of C source code and the translated English equivalent. Both samples need to be processed before training. The English is tokenized. C is parsed into a syntax tree, and further processing is done with head insertion and simplification. A language model is made from the tokenized English, and word alignment models are made from the parsed C code. Travatar is then trained with the processed data, and out comes a trained Travatar model. After training the tool, obtaining a translation is as simple as inputting a file with C code. Pseudogen will make a syntax tree and use a trained Travatar model to generate the English pseudocode. In the upcoming demonstration, you will observe that Pseudogen is able to recognize function declarations and variable declarations. It has learned to generate pseudocode based off of the type of code statement, even with varying variable or function names and values. And further training data and refinement of tree processing will further improve accuracy. The next part will be a demo where we walk through the training process and demonstrate the tool in converting both Python and C to English pseudocode. In this video, I will be demonstrating the open source translation tool called Pseudogen. Pseudogen can translate Python to English pseudocode, and in this demonstration, we have also extended the tool to be able to translate C to English pseudocode as well. The tool uses Statistical Machine Translation, namely tree-to-string translation and phrase-based machine translation. Before I run the tool, I'm going to go over the process of how to get training data and to train the tool. The training data consists of code and the pseudocode corresponding to each line of code. Here on the left, we have samples of various sorting algorithms in C. On the right, we have the pseudocode that corresponds to each line of C. And the training data covers different types of statements that can be found in C, such as function headers, basic variable assignments, for loops, and if statements. All of these statements in the code have corresponding statements in English on the right. And this is what the tool will use to train itself to be able to translate C code to pseudocode. However, further processing is needed before the code and the pseudocodes can be used to train Pseudogen. First off, the code needs to be parsed and formed into syntax trees. This can be achieved by using a parser or a compiler suited for the code. For C, I used a C parser to be able to tokenize and to form the abstract syntax tree for each line. For the pseudocode, since it's in natural language, there are many resources out there that are able to tokenize natural language. After the pseudocode has been tokenized, and the code has been tokenized and made into syntax trees, there is still some processing needed to be done to the syntax tree to be able to make it easier for Pseudogen to train itself using the syntax trees. The processes are called head insertion and simplification. Head insertion modifies the structure of the syntax trees, while simplification removes nodes that are unneeded to the translation of code to pseudocode. After processing the trees, we have the final form of the training data. And each line can be split into 3 parts. The first third of each line is the original C code. Here, it is identical to each line of code, except it has been tokenized, and each special character has been replaced with a temporary placeholder, such as the left round bracket is now LRB, and the asterisk is now aster, the right bracket is now RRB, and so on. The second portion of each line is the pseudocode, and the third part of each line is the process syntax tree with head insertion and simplification performed. And in this format, the training data is then fed into Pseudogen for training. As stated before, Pseudogen uses tree-to-string translation as well as phrase-based machine translation. So training will consist of performing word alignment in order to create phrase tables of the C and corresponding English. First, I'll be demonstrating the original functionality of the tool, which is Python to pseudocode translation. Here in Pseudogen, I copy and paste the following Python code, and Pseudogen generates the following pseudocode. Here, Pseudogen is able to recognize and import an array declaration, a for loop, and function calls. The tool is able to list each element in the array. It is able to read the for loop, and it can recognize the function call as well as the argument used in the function call. Now I will be demonstrating our extended version of Pseudogen, which can translate from C code to pseudocode. And in this tool, it takes in a file of C and it outputs a pseudocode file. This is the original C code, and this is the pseudocode that was generated. Here, it can recognize the name of the function as well as the return type. It recognizes that the statement is a declaration of the following integer and variable name. It can recognize a function call as well as the argument of the function call. And it is able to recognize a for loop and to translate it in English. Now, as you can see, the result is very close to accurate of the code. And in the future, with further training data and a refinement of the method used to process a syntax tree, then the results will be made to be even more accurate. No. This has been a demonstration of the Pseudogen tool and the extension which translates from C to English.